Hello everyone, I'm going to talk about the system design, problem design a URL shorter. For example, this one is the URL shorten service that converts long URLs into shorter manageable links. For example, like W something here, it can shorter than this way. So input, output. Okay, I will follow this structure. First is requirement and con entities, API, high-level design, and deep dives. So let's see. So for the function quality requirements, we have the users can create the short URLs from the original URLs. And option customer alliance, option and expression time. Users can access original URL by visiting the short URL. And for the non-functional requirements, this is non-functional requirements we're discussing in the deep dive. The first is ensure uniqueness of the short URLs and low latency redirections available is larger than the consistent. This should be checked with the, this is conditions. And scalable to 1B URLs and 100 millions daily average user. So this is the requirement. And then we have the con entities. Con entities treat it as like a database. How many data you want to do it? It's kind of like this original URL we need, and the short URL and the user information. This is input, this is output, and some like a user can log in, some information about. When you it's kind of treat like a thing about the database when you how many tables you need. So this is the con entities meaning here, like data part. And for the API, we have to satisfy like this. For the API, it's kind of like in normal, each function requirements will create one API. So we can check the first. The users can create short from the original URL. So it will kind of like create, right? So we need to post something here and the long URL and expert time, customers alias. So this is the first requirement. And the second is users can access original URL by visiting the short URL. So we have the get, right? Get the original redirect, get the short URL. When we call this URL, it will redirect it to this one, original one. So redirected to this is get, and the status will 302 means redirected. And this 302 is temporary. Yeah, this is the API part. Now we're going to talk about the high-level design here. High-level design is like this. So we have the client. So high-level design is kind of like make sure the first requirement, this API and entities displays in the graph. So we can start from the first API come, right? So we have based on the com, we have the client, like a short URL, like database here. So we start from the first, like post create URL client. We have the client, and primary service is kind of like do some logic thing and database to store the com entities, data information. So when the client posts the URL, we got the primary service, it's kind of like create. So we have the function, it's kind of like generate short URL and save to the database. And for the database, we have the short code, like store the like a URL, original URL, and create time, expression time, create by some user. And also we need a user, just simplify this, user ID. So this is the first API calling. And also second one, right, we got like a get redirected to the original URL. So clients call this function, call this API and go to the primary And then the primaries will have the function is called like read to look up the original URL in the database, and the returned with the 002 read directly to the original URL. So this is temporary. And we also have 301, that is the permanent. That is kind of like a store, that is improve the performance, but it also costs some space. So normally it's just to use a temporary to do this. Okay, this is a high level design here. Okay, now we come into the deep dive. So the deep dives is we have the non-function requirements. The first is ensure the uniqueness of the short URL. So I use the different colors to do this. So in this one, when we have the these clients call something here, so we can ensure we can use like global counter based the 62 in count, and this is kind of like functions can make sure the atomic the way, which means that every generated URL is unique. And when you write it, write a service kind of create a short URL. So we can use this way to make sure the unique of the short URL. So for the low latency and the redirections. So for the low latency redirection is based on the read function. So we can use like a cache Redis to improve the performance. Like we can use like a key short like value to get the information better than call the database. Because we have to check the cache first, because the cache is it uses the memory. Memory is much faster in the disk. So we can hit this first level and then go to the second level to find a database. If we are lucky find what we need from the cache, we don't need to check anything in the database. So this is the way to satisfy the low latency redirections. So let's see about the availability less than the consistent. Okay, so available, right? So I need to make sure, for example, when a database just shut down, whatever encounters something like disk loss, right? So we can use another way, like we can use the database replication to duplicate the information. When this database gone, we can use this one. So this can make sure it will not impact or we are data losing, not available to get the information. So this is a way to make sure the availability larger than the consistency. So okay, so this is the fourth, scalable to the 1B URLs. So original, we can see this one is kind of like just a monolithic architecture. To improve this way, we have to use the microservice to separate the service. So we can separate like write service, read service into the micro service architectures. And also we can use the API gateway, right, to route the correct microservice. When the clients post here, it will directly, okay, so call the like post, so it will redirect it to the right way. So it's kind of like a separate the everything original just in one computer. Now we have multiple computer or multiple servers can handle the lot of the requests. So this is the way to the scalable to 1B URL is 100 million data daily average users use. Yeah, thank you.